Alright, take two. Camera's not even straight. Because it's the second time I'm videotaping this. Alright, let's try this again. This is for Past 7, Earth's Atmosphere, Chapter 2.2. And there are three things that we should talk about. The first thing is the Coriolis effect. This is probably the hardest thing, probably in the whole book. I know I say that a lot of times, but this is true. So I drew an example or two examples to try to explain the Coriolis effect. And the Coriolis effect, the most important thing you should remember is that it's about point of view. Who is looking? And here I drew a picture. Imagine this person. This is the Earth, and this is North America. Imagine there's a person that's walking from the top of North America to the bottom, right? To him, it looks like he's walking in a straight line. I'm just walking from north to south. And while that may look true, think about what would happen if an alien came. There's an alien. If the alien stood watching this person, and it took him 6 hours for that to happen, well, in 6 hours, the Earth is actually rotating. And it rotates 1/4 of a whole turn, because one day is 24 hours, right? 6 times 4 is 24. So after 6 hours, this person's actually over here somewhere in the corner. So to the alien, it looks like he walked in a curved pattern. It doesn't look like he walked straight because the Earth turns. So now North America's over here. So it looks like he walked like that. That is the Coriolis effect. It is because of your point of view, it looks like there's a force, something pushing you that make you go that way. And because wind is a gas, it's not completely attached to the ground, wind acts in the same way. Wind wants to go from north to south, right? But the Earth is spinning. So because the Earth spun without the wind attached to it, it looks like the wind moved that way. So here's another example of your point of view. Imagine I tie this ant, because I am a cruel, evil scientist, to a fan, and then I turn it on. To me, it might seem like, oh, this ant is moving very fast. But if this ant hangs on, to him, it might not make a difference. It might look like, hey, that person is moving very, very fast. Because to him, this is a normal walking pattern. He can just walk straight through that. So that is an example of the Coriolis effect. Hope that cleared things up, maybe. Jet stream is another one. Jet stream, if you've ever traveled, you might have seen that airplanes sometimes do not travel in straight lines. Well, there's a reason for that. Sometimes they want to ride a jet stream. The wind is moving this way. Why do they want to do this? Well, gas is very expensive. In fact, in an airplane, it is the most expensive thing. It pretty much determines the price of the flight. So if gas prices go up, flights go up. But the airplane company wants to save some money, so they try to ride this free jet stream. It's like a little push on the airplane so that it can get there maybe a little bit faster without stepping on the engine so hard. And if you want another example, you can look on page 55. Page 55 shows you the jet streams across the United States and the patterns that the airplanes try to fly. So it can help you save some gas. And a company is about profit. They want to save as much money as possible. The last thing is about deserts. Why are we talking about deserts? This is an interesting picture on page 51. It shows you the patterns, and we will refer to this page more than one time. So keep an eye out for that. Page 51 shows you where wind goes in and wind comes out. And this was talking about hot wind. And it was telling you that hot wind or warm air falls at 30 degrees latitude. This is latitude. If you were in past 6, you probably saw this already. 30 degrees latitude has a special name. It is the Tropic of Cancer, and minus 30 degrees south is the Tropic of Capricorn. Why are these important? Well, because the warm air is falling at these places. If you look at a map like this one, you will see that many of the world's deserts lie on these latitudes. Here's the big desert in Australia, the Sahara Desert right across the 30. Some deserts right here in North America, some deserts in South America. These deserts are close enough. Those are the world's deserts, and they lie there because of this wind pattern, this dropping of hot air. And when the cold air drops, like rain, for example, rain, where it rains down is at 0. That's why you see a lot of tropical rainforest there. And also at 60 degrees. 60 degrees is somewhere up here. You might not think of it, but actually if you see a map about forests, you'll see that there are some forests up here, like pine forests. Here there's not much land down here, but up here you'll see it actually rains a lot up there. And that's one of the reasons why countries like Iceland, if you ever see Iceland in pictures, you'll see it's very green. It rains a lot there. England as well, rains a lot. This area where the 60 parallel lines, the 60 latitude line, there's a lot of rain. So that's the effect wind has on these things, on the earth. All right, thank you, and that's all. Goodbye.